Every model airplane, whether powered or gliding, needs to be straightened at first. Most people will probably measure it with a ruler. However, this is difficult, inaccurate, and in the end annoying. To make rudder adjustment a little easier, there's the GliderThrow. A sensor is attached to the rudder using a magnet, and the readings can be read off to the nearest tenth on a mobile phone or PC. These readings are available in both degrees and millimeters. Watch the video to find out exactly how it works and what you can do with the GliderThrow. Let's take a closer look at the GliderThrow first. Each sensor is equipped with a gravity sensor. When it is horizontal, it senses that gravity is coming vertically. If the sensor is now tilted to a certain position, it uses gravity to determine the corresponding inclination. The sensors always show the inclination in the sensing plane. That means this inclination here, not right or left, but forward and backward. Since the third version, a rechargeable and replaceable lithium battery is built in. When the USB-C charging cable is connected, another red LED is visible, which turns blue when the battery is fully encharged. Next, we will take a measurement on the Riddick. Switch on the sensors and attach them to the rudder with a magnet. It is important that they are parallel to the hinge line. We then connect via Wi-Fi using a tablet, mobile phone or laptop. To do this, go to Settings, then to Wi-Fi settings. You will now see the Wi-Fi GliderThrow. We will use this. The first time you connect, you will be asked for the password 1234567889. This screen will open automatically. This means you don't need an application. If the screen does not open automatically, enter 192.168.4.1 in your browser. Here we can see sensor 1 and sensor 2 and their difference. That means sensor 2 minus sensor 1. Both sensors can also be reset to 0. Here we see the whole thing displayed in degrees. We can also display it in millimeters. To do this, tap on Go to Menu and then on Throw View. We only need to enter the chord, which is the distance from the hinge line to the end edge. So we tap on Config's surface chord. There we can enter this value. In my case it is 50 millimeters. Because I have both of them attached symmetrically, I have the same value, but it's also possible to enter different values for sensor 1 and sensor 2. If we don't want to save it, tap on Go to Throw page. To exit and save, tap Save and Return. These values are now permanently saved until they are replaced by new values. And again we see that the path is displayed. It is calculated using the chord set. These two options will be sufficient for the most people. From the third version onwards, there will be a menu that you can use to access these two options. Click back to Home to return to the home page and Throw View to display the inclination in millimeters. From the third generation, there is also asymmetric control. For example, if you want to set the ailerons to fly rows or a V-tail, you can select asymmetric differential in degrees or throw asymmetric differential in millimeters from the main menu. The only difference is that the difference displayed is the sum of both sensors. If sensor 1 moves 1 degree up and sensor 2 moves 1 degree down, the difference will be 0. Next is the number of sensors. If there are more flaps than here with the Riddick, you can add more sensors. Up to 8 can be used at the same time. The following combinations are possible: either sensor 1 alone or sensor 1 and 2 together, or sensor 3 alone or sensor 3 and 4 together, or all 4 as a quad. Important: sensors 5, 6, 7 and 8 can only be used in connection with the third sensor. The procedure is exactly the same. For example, if we have 4 sensors, we switch them all on and go back to Wi-Fi settings. The Wi-Fi GliderThrow is for sensor 1 and 2, but as we now have 4 sensors, we use GliderThrow 4. We may also need the password 1, 2, 3, 4, 5, 6, 7, 8, 9 again. This takes us to the start page, which shows us sensor 3 and 4. There we can also switch back to millimeters. To do this, we also need to enter the chord. It is probably important to mention here that in order to set the chord of sensor 1 and 2, we need the Wi-Fi GliderThrow, which is exactly what I used at the beginning with sensor 1 and sensor 2. We then set the chord there and it remains stored. We can also view all 4 at the same time. You have to tap on Go to Quad page, and here you can also reset them all. You can switch back to millimeters as well. With the GliderThrow, it's possible to measure the angle of incidence. This requires 2 sensors and the EWD support. If you are more interested in measuring the angle of incidence, there's a detailed video above. If someone does not have a mobile phone or PC but already owns the GliderTimer, they can also connect the GliderTimer to the GliderThrow and get the values displayed as well. You can also use the GliderThrow to set the engine camber or measure the angle between the wings on a biplane. As you can see, the GliderThrow has many applications. How do you use the GliderThrow? Tell us in the comments. Finally, a short summary. With the GliderThrow, you can easily adjust the flaps, and the values are displayed in both millimeters and degrees. They can also be used to determine the angle of incidence. Up to 8 sensors can be used at the same time. Depending on the number of flaps, 4 sensors are sufficient in most cases. At the bottom in the info box you will find the manual and the link to the Mammoody online shop where the GliderThrow will be available. I hope you now have a small impression of GliderThrow and can try it out for yourself the next time you set up your glider. Thanks for watching.